Hey guys, welcome to Algos Explained. My name is David Kim, and today we're going to go over a problem called, or well, it's not called anything. It's you're given a string, and you're given your output is a string, and what you have to do is delete pairs of letters. Okay, input's a string, output's a string. We're going to be deleting pairs, and what we want is kind of okay. If that's a pair, we want an empty string. If we have that, we want an A, because we just want to delete pairs. We don't want to delete duplicates or every single letter that was a pair. We just want to delete pairs at a time. And so something like this, we want to delete the BB, and also we want to delete the AA. So pretty much our output, the condition is our output don't give me any pairs in it. If I give you something like A, B, B, C, C, A, don't give me AA because that's a pair. After you deleted the BB, after you deleted the CC, yeah, don't give me the AA. If I give you something like BC to work with, you could give me back BC because there's no pairs in there. There's duplicates, no pairs, and throughout this video you might hear me say duplicates. I always mean pairs. I realized I made a lot of that mistake in the first run. But anyways, yeah, this is going to be recursion. And so how do I know that by listening to kind of the objective or kind of our action, what we need to do, how do we know that this needs to be recursion? Well, if you're not familiar with recursion, kind of recursion is calling the same function within that function. It's kind of like looking at two mirrors together. It's like that mirror is looking at him, he's looking at him, and they're just constantly, boom, they're going into each other infinitely. With recursion, in regards to programming, we definitely don't want to do infinitely. That's called Stack Overflow, and we don't want that. And I'll explain kind of later what Stack Overflow, how do you get that later, and how do you avoid it. And so looking at this problem here, how did we know that it's going to be recursion? Well, first of all, everything that can be done recursively can be done iteratively, but sometimes it just makes more sense to do it recursively. And at first it might be hard to get to wrap your head around it, but you'll get there eventually, trust me, if you're not already there already. So by looking at this, how did I tell? Well, I knew because something like this. With this example, I would have expected to be giving them AA, and I thought they would be okay with it, but they're not. So pretty much after one run, they want kind of that action to be completed again and again until I have like a super refined output. And by refined, I just mean no pairs. And so kind of thinking about your function call, your recursive function call to do one thing, and if that one thing is deleting pairs, how do we guarantee that the last output we give you guys, or we give that person or the interviewer, how do we guarantee that that last output has no pairs in it? Well, if our function deletes pairs, we can have an output, and then we could run it through that function. It's kind of like filtering water, you know. How do we guarantee that our water is going to be super clean? We'll run it through the filter multiple times. That's how you for sure tell, or just buy a really good filter. But yeah, if you have a bad filter, just filtering it multiple times, that's how you know for sure. That's kind of what we're doing with the recursion. We're going to send it into that function again and again until we know for sure, okay, we can trust this water back, we can trust that it's drinkable, we can trust the output that it is what we want. And kind of, when do we know that we have what we want? Well, through base cases. And so when you're thinking about recursion, you're always going to be thinking about base case, kind of thinking about where I should stand here. Because without a base case, you'll get that Stack Overflow, and you'll see it again later as I explain it to you. But when you think recursion and when you're starting off recursion, don't start off with kind of what is the main purpose of this function going to be. Of course, have that in the back of your mind. Sorry. Of course, have that purpose of the function in the back of your mind, but something I would arguably say is more important is how am I going to end this recursion call? Kind of what is the minimum state, what is the minimum input that I could receive to kind of shoot out an output right away without even having to look at the rest of the function. And so in regards to our problem here, how do we know that guaranteed our input's not going to have an output? If we have something like this, BC, we can't guarantee that because we would have to look through this guy. We would have to look through, maybe with a for loop or something, we have to look through him to kind of know, okay, to kind of guarantee that has no pairs. How do we know for sure just off one glance that it has no pairs? Well, it can be of length 1 or less. Because if it has just a single character, if our function call reduced has a single character, then that can't have a pair. It takes 2 to make a pair. If we have 0, if we throw them in a null string, or if we throw them in just a single character, well, hey, there's no way that can be a pair, so I can just freely return that back to you without worrying whether I gave you the right thing or not, because I know for sure I gave you the right thing. And so that's kind of where you should always start with base cases in terms of recursive functions. That's our recursive, that is one of our base cases then. If the string is of length less than 1, we know for sure it's either 0 or 1, and so we could just return a string. And so in a case where we have maybe A, we could just return A again because that has no pairs. We just want to make sure that our output has no pairs in regards to what our input was. So there we go. That's our base case. Now onto the meat of the problem. How do we delete pairs? Well, deleting pairs not that hard. We have a string, and one thing to understand, or one thing you have to remember about strings, is that you can't simply kind of replace characters with like empty strings. For example, if you have a string hello, you can't just replace str of 0, 1, 2, 3, 4. You can't just replace string of 2 with like a null string. You can't do that because strings are not rewritable like that. What you have to do is you want to either do some flipping it to an array magic, or you want to slice. And what we opted to do here is slice it. What happened right here in this line of code is we took the string and we just gave it a new variable, reduce string. More reasons for why down here, but we'll get to that later. Pretty much right here, this is kind of how we're going to delete or get rid of those pairs. And so if we read through the code, it's just a simple for loop. We're going through it, starting at 0, we're making sure it goes to the length of the reduced string, and we're incrementing it by 1. We're going to just check, okay, is the reduced string at that index equal to that the value at that next index? So pretty much if our I is, well, let's start at 0. If I is 0, is H equal to an E, so 0 and 1, right? That is not, so we're just going to skip that if conditional, go to the for loop, having incremented the I, so that's 1. Now is the E equal to the L? No. Increment the I, now is, well, what's that I of 2? It's the L. And now I of 2 plus 1, so that's another L. So these are L's. Now are those equal? Yes, they are. So now we're going to go into the slice magic. And if you're not familiar with it, a quick refresher is that the first argument is inclusive. The second is exclusive. And if you don't have a second argument, then it just takes it to the end. What I mean by that is, say, if we have, so let's get rid of these double L's. What's going to happen here is we're going to get rid of the double L's by replacing reduced string as a representation of this plus this guy. And so what happens here is we're slicing from 0 to I. And so let's see, 0 to I, what is that going to be? That's H all the way to the I, which I right now is 2. And so all the way to it, and remember the second argument is exclusive, which means it's not going to be included in that little slice portion. And so we're going to have 0 and 1. So HE plus, that's a really bad E, plus whatever is here. And so now we did plus 2 because we want to skip it. Now, our index right now was 2. And so that's 2 plus 2, that's 4. And so we're going to add whatever was at the 4, which is the O. And so now that's kind of what reduced string is now equal to, HEO. And our index was 2. And now we are going to do, well, we're going to increment 2. So now our index is 3. But our reduced string's length is now 3, so we're just going to cancel out of that. And well, you might say, what if I had hello O like that? This might seem kind of bad. This might be this might sound like a bad situation to you because, well, now after we took out the double L's, we'll have that. But what are these indexes? 1, 2, 0, 1, 2, and 3. Our index would be 3, and it would kind of ignore this double O. Well, that's why you have to trust the recursion. Our next recursive call is going to catch that, and we have to just trust that recursion to do one thing at a time, and that one thing was deleting the pairs that we saw on one run, and we're going to let the next run take care of whatever was created after that. So we're not going to worry about kind of these cases because recursion is going to take care of it. Cool. So that was just going over this for loop here. So we know we can trust that it does get rid of these pairs, and that it returns kind of the new string collapsed, pretty much, or the old string collapsed with the pairs gone. So I think now it's time for some examples. Let's walk through this AAA. A. And so now, what is our function called? It is reduced of this AAA. And this arrow is going to represent what it returns. And so we really care about what goes on this line because that is our initial call. We care about most what goes on that line. Well, of course, we care about what every single thing returns, but that is kind of what we're going to be seeing on the screen if we see something on the screen. And so we're going to go here, skipping the base case, simply because you could already tell it has a length greater than 1. And so reduced string is equal to that, so is string. We're going to go through the for loop, and what we did was we deleted a pair. So now we're left with A. And so now we go through here, and this little bit, I'll just explain it right now. We'll see it work later with this last example. But what it does is it checks, okay, did something change? And yes, it did change. That was the initial string. Well, that's that value. And now reduced string turned into just a single A. So we're sending, well, this first call is returning another call. And that other call is reduced of A. And you can see because that was now our return string, it's returning this call right over here. Sorry, that's the worst ever. I can do better. Is returning the function call with that argument now. And so now what does this guy return? Now what this guy returns is going to be what this is, and that is going to be what that first one returns. What does he return? That gets caught at our base case, and that is less than or equal to 1. It is 1, so we're going to return the string, which was, what is the string? Well, it's the argument, and so that's the argument, and it's going to return that. And so if this function call turned into this, now that initial call returns that. And so that's what happened right there. I think the best way to think about it is think about dominoes. Every time you return a function call, you're placing another domino. And every time you kind of finally return something that's not another function call, or not a function call to the same guy, another recursive function call, at that point, what you did was you knocked the dominoes over. And that is what we kind of call bubbling up. Once you return the dominoes, or not return the dominoes, once you return something that's not another function call, now all these recursive calls can start returning something. And so, yeah, think about it as dominoes. Every time you do another call that's placing another domino, once you finally return something here, you started that bubble up effect. Cool. And so let's go over kind of this example here, or actually, yeah, let's go over that example. It'll be the same length as that one. A, B, B, C, C, A. And so reduced A, B, B, C, C, A. Okay, and so pretty much let's just go over this really quickly. I want to get to this example over here. Going through here skips the base case. Reduced string is equal to this guy. Same as the string. What it does, it'll get rid of BBCC. Pretty much everything that's already a pair perfectly together, it gets rid of. And so in this one call, it reduced string equals that. And you're wondering, okay, why didn't it get rid of that? Well, that was created by this for loop. And so therefore, that's kind of what we're left with. That's reduced string. And so we go down here. Was reduced string equal to the string? Well, no, those are two different things now. And so what this initial call is going to return is this call over here. And so it's going to return a function call AA. And now what does he return? Now what does he return? That's our string now, right there. Still doesn't get caught by that base case. Reduce string, that. Now let's go over here to the for loop. And it does, it gets rid of it. So kind of reduced string is now a null string. Is reduced string equal to the string? No, those are two very different things. And so we're returning a function call again. We're still placing dominoes for now. Reduced of that. And now what does he return? Finally, we got caught in this base case and we return the string. We return whatever was the argument, and that is a null string. And so now what he returned becomes who he is. And so now that's their null string. This is a null string here. So now this guy becomes a null string. And now finally, what is that initial call return? The null string. And that was kind of how it bubbled up. And exactly when we placed that last push, or placed the last domino, then pushed it. And so now let's go over this last one. This is the last one we're going to go over, BC, BC, BC. And I hope this is still recording. Reduced BC, BC. So what happens here? Well, it's not less than, it doesn't get caught in that base case. And it'll go through here, but there's no pairs. And see, we're not interested in forcing pairs to happen. We just want to delete the pairs that are there. And if new pairs get created, then we'll delete those too, but we're not going to force it. We're not going to secretly take out one of those C's to force a B in there, or force a B pair. We're just not going to do that. And so what's going to happen is, if we didn't have this bit of code right here, if we didn't have that, what would have happened was that Stack Overflow. Pretty much it'll go through this, and what does he return? He'll return something over here. It'll try to reduce the string, reduce the pairs, get rid of the pairs, but it won't succeed. And so if we didn't have this code here, it'll return the function call reduced of BC, BC. Why? Because reduced string wouldn't have changed. Reduced string is just that string. And so guess what that returns? The same thing. It'll return, that's the string here. It'll skip that. It'll go through the for loop, but it won't find any pairs. And so it'll just return a function call. And so not being unable to catch something like this, that will cause a Stack Overflow for you. And if you ever see me kind of just like looking at the camera, I'm trying to see if it's still recording. I'm paranoid now. Yeah, so how did we solve that? Well, we solved it by this over here, which stated, okay, well, even if it's not, we have to understand, even if it's not an input of length 1 or less, it can be an input like this that has no pairs. In that case, we just want to return that. And so at this point, we return, if we went through the for loop, and we do every time, we try to reduce it, but there's nothing to reduce, therefore just return it, because we're not going to force it. And if our input was like an AA, BC, BC, that will still work too. This will still come in handy when we get to the point where that is our function call, or that is the argument for our function call. It would have probably been reduced, AA, BC, BC, and then that would have returned reduced, BC, BC, and now that would have returned BC, BC. and then it would have returned BCBC at the very end. Cool. Hopefully that was just a walkthrough, I guess. It wasn't a full-on actually, you know what, call it what you will. I didn't do a live coding for you guys, but hopefully that walkthrough was good. If you liked it, let me know in the comments. Definitely want to hear what you guys have to say. I think that's it for this guy. We went over recursion, we went over base cases, we went over bubbling up. Yeah, I mean, maybe the next step is memoization, but that's like another level. If you guys want to know about that, let me know. But for now, that's it. If you liked it, give it a like, comment, and subscribe to my channel. I post videos every Sunday. And so, yeah, I'll see you in the next one. I'm David Kim, and this is Algos Explained. Catch you later.